Okay, guys, so with polynomials, it might not be so clear as to what the zeros are, but there is a useful thing we can do to find the rational zeros. And to do that, what you have to look at is this first term and this last term. So, if you take the positive and negative values of the last term, so the multiples of it, the multiples of 2 are positive and negative 1, and positive and negative 2. Okay, so those are the only two. That's what this part over here is showing. Okay, and I'm just explaining it while I do it. Now, what are all the multiples of 15? We have plus and minus 1. Actually, I'm not going to write plus and minus on the bottom because it's not unnecessary. If you do plus and minus on the top, you will get both the positive and negative values. And if you have negative and negative, you get positive and things like that. And so we can't actually do that. So we have 1, 3, 5, and 15. Those are your multiples for the bottom. Okay, now let's look at our values. So the first thing we could do is we have plus or minus 1, because 1 over 1 is plus or minus 1. 2 plus or minus 2, that's a solution because that's over 1. Okay, now the next one, we're going to do this one and this one. So we have 1/3 plus or minus, and 2/3 plus or minus, and so on and so forth. 1/5 plus or minus, 2/5 plus or minus, and finally 1/15 plus or minus, and 2/15 plus or minus. Now that's a lot of information. You have 1, 2, 3, 4, 5, 6, 7, 8 times 2, 16 different possible rational zeros. And you can get them by synthetic division, so that's what we'll try first. So we're going to try, let's try 1. So what I'm going to do is test each one. So I'm going to take 1, positive, and we're going to do 15, 14, -3, and -2. Okay, well, it gets better once you get rid of one of them. So if we go 15, 1 times 15 is 15. That's 29. That's way too big. So 1 is not going to work, but let's do -1 instead. So if I do -1 here, this is -15. The reason I knew that's too big is because 1 times 29 is going to be some big number. It's going to stay big, and then it's not going to make 0. You're trying to get a 0 for the remainder. That's what the goal of this is. If you get the 0, that means that it is a divisor of it, and therefore it is a factor of it. So this is -1. This is +1. That's -2. That's +2, and that is 0. So -1 works, so that means x plus 1 is a factor. Okay, so what is this new thing we have? -15. Or no, I'm sorry, 15x squared minus x minus 2. Now that we have this, we can maybe try snowflake method to get the other ones. You don't have to, I mean, you can, okay, let me show you another way. We can still do the same thing we've been doing. So I think what I need to focus on here I think okay, so since we got one, let's try -1 again. It's not going to work, but let's try it. If it works, it works. If it doesn't, so what I'm going to do is I'm going to use the new values, these ones, and I don't have to worry about the first ones anymore. It will work if you use the first ones again, obviously. It'll give you the same thing, but if I use the new ones, let's see what happens. So if I go 15, 15, 1 didn't work, so we don't have to try that again. -1, that's -15, and that's not going to be good, right? Because that's -15 minus 1, that's going to be -16, and then times that, that's not going to give you 0 here at the end. So we -1 and 1 are gone. Okay, that is not it. We need to try something that's going to shrink this considerably. So let's try, I don't know, 2/3? No, 2/3 might, yeah, let's try 2/3. Maybe that'll work. So let's do 2/3. So 2/3 of 15 is going to be 10. So this is -10. It's not going to shrink it enough. So 2/3 didn't work. So this would give us -11, and then that's going to give us a fraction, and that's not going to give us 0 with that. So that's how I knew to stop. Let's try 1/15. Maybe that'll work. Well, if I do 1/15, this is 1, so this is going to be 1. 0, so that's 0, and that's -2. That didn't work. If I do negative, then I get -2 here. -2 times that's not going to give you 0, so that didn't work. All right, so as you can see, like, you can keep trying these. You'll keep getting ones that work, ones that don't. Let's do the x method just to get this out of the way pretty quick. So 15x 30 negative, and we want it to add up to -1. 6 and 5, I think. 6, 5, and 6 is the negative. Okay, let's simplify. This is going to be 3/1, so this is 3v plus 1, and this is going to be 5 and 3, so this is 5x minus 3. Okay, so let's solve these real quick, and we'll know which ones will work with the synthetic division, and then I'll use it on that other one to show you. Okay, so we got that. We've got 5x minus 3, so I'm sorry, this is 2. I knew something was up with that because 3/5 is not one of our solutions from above. Okay, that's better. So then this is going to give us 2/5. Okay, and this one would be -1/3. All right, so let's try these. So we have 15, -1, and -2, and I just want to make sure that you can see that these two will work. So we have 2/5. Okay, so 15 comes down. 2/5 is going to be divided by 5. That's going to be 3 times 2, 6. So if we go, this is -1 and 6, that's 5. Divide by 5, that's 1 times 2 is 2, and that's 0. So that one worked. Okay, so we got this one to work. And then finally, -1/3. And then 15 and 5. So we drop it down, 15. 1/3 of 15 is -5, and that's 0. And you can see that all three of those work. Therefore, those are the solutions to this polynomial. And they all are on this list. So 1/3 is here, positive 1/3. And, or I'm sorry, -1/3. And positive 2/5. And then obviously -1. Okay. So it's a little bit of work. So let's do another one. Let's do, this one's going to be nicer. We have x to the third plus x squared minus 5x minus 2. So the multiples of 2, plus or minus 1, plus or minus 2. And then the multiples of x to the third's coefficient, which is just 1. So there's only 4 solutions here, plus or minus 1, or +1, -1, +2, -2. So this should go kind of quick. We have 1, 1, -5, 2. Let's try 1 first. Drop it down. 1 times 1 is 1, so that's 2. 2 times 1 is 2. -3, and -3 is -1. That one didn't work, so we can get rid of it. Okay, let's get rid of all this. So +1 did not work. Let's do -1. That's 1. That's -1 and 1. That's -1. That's 0. We do 0 and -1. That's 0. -5. That's not going to work. Okay, so -1 did not work either. Okay, next one. So 1 does not work. So 2 better work. 1. So this is 2. This is 3. 6. 1. 2. Didn't work because this is 4. So now negative 2. Negative 2 should work. This is going to be negative. And let's see. Negative 1. That's going to be what? This one's not going to work either? What is going on here? Or am I doing something wrong? 1, 1, negative 5, and negative... Oh, this is negative 2. That's what my mistake is. I didn't write the negative. Ah. So 2 did work, didn't it? Okay, so then let's do positive 2 again. Sorry about that, guys. Forgot a sign. You can't forget the signs or else bad things happen. So this is 2. So this one's 3. 6, 1, and 2. Okay. And that's 0. So 2 works. Let's try 2 again. 2, 1, 3, 1. So they can work multiple times, so just so you know. So this is going to be 2, 5, 10, 11. Okay, that doesn't work. Let's do negative 2 now. So this is negative. This one doesn't work either. So this is 1, negative 2, 0. I'm sorry. It's not 0. That's negative 1. Didn't work. Okay, so there's only one real root. It's 2. And let's look at what was left over. It was x squared plus 3x plus 1. Well, x squared plus 3x plus 1 is not factorable, so we know that's good. Let's find the 0, or let's find the vertex. X equals negative b over 2, or negative 3 over 2 times 1. So at negative 3/2. Okay. So let's plug that in. That's going to be 9/4 plus negative 9 over 2 plus 1. So this is going to be 9/4 plus, nope, sorry, minus 18 over 4 plus 4 over 4. Yeah, that looks right. And so this is going to be negative 9 over 4 plus 4 over 4, which is going to give us negative 5 over 4. Okay. And so that would be negative. So that means this does have a solution. If you run the quadratic formula, it will work and it will give you a value. So I hope that helps, guys. If the quadratic formula will give you a real solution, it just won't be rational, which means a fraction. So I hope this helps, guys. Make sure you're practicing. Do your best. Thank you for watching.